section. Okay, so marginal cost. It's basically the derivative of cost. It's another way to think about that. It's the derivative of cost, it's the marginal cost, or it's the function that measures the change in cost. Okay, marginal revenue, all of those things, change in revenue, R prime, it's the derivative of revenue. Marginal benefit, marginal profit. Marginal means change in economic terms. Okay. Our goal is to find the cost function. Okay. And in addition to the information we have here, oh, they don't have that. Okay, I'll make up something in a minute here. Let me think about this for a second. Hang on a second. So that's going to be, so that's going to be 8136. I think that's right. All right, I think. Okay, we're going to go that. All right. And we're going to find the cost function given this marginal cost function and given the C value, the cost value at 12 is 8136. Okay. So this is kind of a combination of several lessons. Marginal cost to cost, derivative of a function to the function, that's an antiderivative question. So the first step in this problem is to find the antiderivative. And I think, did I write this with a T? I apologize. Nope, yeah, I did. Sorry about that. That should be an X. All right, so our first step is we're going to find the antiderivative. Antiderivative. The antiderivative of the marginal function is the function. Okay, so the marginal cost antiderivative is cost, marginal profits antiderivative is profit, marginal whatever's function is the whatever. So antiderivative was the new trick we learned. So 675 plus 0.5x dx. The dx is really just there to indicate the variable that we're taking the antiderivative in terms of. It's really only super important if we were in a multiple variable scenario. It's a standard part of an antiderivative or an integral problem. Okay. So from the lesson on, I don't remember what day it was. We started it when we were taking our first set of antiderivatives. We're undoing the derivative. So the antiderivative of a constant is a constant times x. And then the antiderivative of a monomial term of x with a coefficient of 0.5 is going to be 0.5 x. We're going to add 1 to the exponent and divide by that number. And then we always have a plus c. I did say back in the day we're going to use a k in this case because we're talking about a cost function, and cost is already sort of taken up the C for us. So using a K instead of a C to represent the generic constant is sometimes what we do in economic problems. All right. Everything I did there comes from kind of this idea, the idea that when we take the antiderivative of x to the n, it's x to the n plus 1 divided by n plus 1 plus c. That went along with the assignment that you did on Monday. I did a video where I reviewed how to do that, basic stuff, and then the finding c part. Now, what was a little different on your lab was there was a pre-step to this. The lab started with data that I wanted you to make into a model. So instead of giving you the marginal cost, I gave you equation, I gave you marginal cost data. Instead of giving you the marginal benefit equation, I gave you marginal benefit data. And I asked you to do the regression on Desmos to get the marginal function. So that was a little bit different in the lab. In the lab, you started before this. You started with just data and did some regression to get to for one of them a linear function and for one of them a quadratic function. Okay. If we need to go over the regression part of it, we can absolutely do that. Just a reminder, when we are doing regression things on Desmos, first of all, your table is there of data, typically with subscripts. Whatever subscripts are in your table, you have to pay attention to. And then if we're going to do a linear model is y, and then remember it's a little squiggly guy, mx plus b. If my data table is x1, y1, then that's how I label my x's and y's. If I was going to do a quadratic, that's a x1 squared, bx1c. Okay, so on the lab, the regression part, do regression on benefit data and get a benefit model, a marginal benefit model, excuse me, and then take the antiderivative to get the benefit model, take the cost data, do a regression to get a marginal cost. This is marginal cost data, so you do a marginal cost equation using, I think, quadratic regression on the marginal cost, and then find the final function. Now, the final function aspect, if we take this one more step, this is kind of our, oops, I'm erasing. Go back, stop, undo, there we go. All right. When I have my cost function mostly figured out, except for not knowing the constant, we use the given information, at least in this problem, that was the information that the cost value at 12 was 81.36. This is what we did on the Monday video where we were finding the constant. We did this again on the Wednesday video, but we were doing it with these types of problems. We actually did a little bit more on the Wednesday video. We then did additional work with the function. All we were doing on the lab was finishing the model. So when I talk about C of 12, that's going to be 675 times 12 plus 0.5 times 12 squared divided by 2, which I should probably clean up, plus K. And that is supposed to end up at 8136. So 8136 should be the result of when I plug 12 into this equation. 0.5 times 12 squared divided by 2 plus K. All right, so let's see if I did this right. Oh, I didn't do it the way I wanted to, but that's okay. So let's see. This is 8100. Okay. This, oops, 0.5 times 12 squared divided by 12 squared times 0.5 divided by 2 happens to be 36. And yeah, I didn't mean to do this. I forgot I had to fix because I was trying to tweak this. But in this case, it's fine. It happens. Okay. In this case, I get these add together, and this isn't going to always happen, but in this problem, that means the K value is 0. Okay. The K value happened to be 0. If this number had been something else, you know, if this had been like 8250 or something like that, we would have then subtracted 8136 from it and gotten a different number for K. And all that K number does is go back to our function and become the last little piece of the function. So my cost function, 675x minus, or no, plus, well, let me fix that. How about, if I have a 0.5 and divide it by 2, that's going to be 0.25. So 0.25 x squared plus 0. Okay. That's my cost function. Okay. So taking a look at the lab, this is pretty much what you would need to do questions 1 through 4. Okay. Now the second part of the lab asked you to take a look at the graph you would get if you graph the benefit function and you graph the cost function. Okay. What we're expecting to see if we graph both of those, okay, I think one of them was quadratic and one was, I don't remember exactly what they look like, but let's say we did something like that and something like that. Okay? If that's benefit and that one's cost, what we would be interested in is from that point on, we want to know, when does the benefit value exceed the cost value? Because that would be when we're doing things well or correctly or profitably in our scenario. So once you graph the two functions, your benefit function and your cost function, what you should see is there should be a point where the benefit function ends up above the cost function, and at whatever that value is, that's a good number. If X represents number of items per production, thanks. And let's say this is X equals 15, then what we would recommend is, hey, let's make sure we do our production greater than 15. Because if we're less than 15, our costs are above our benefits. And we want our benefits to outweigh, to exceed our cost. So wherever that intersection point is, wherever the point is where benefit starts to be greater than cost, that's what we're looking for in the second part of the lab. I think that details most of what you would need for the lab assignment. And if you're kind of still sitting there going, I don't really know what you're talking about, Ms. Willenbrock, you keep saying there's some lab assignment and I don't know where that is. Here's where it is. Okay? And here's where everything is from last week. So I did a folder for Monday, I did a folder for Wednesday, I did a folder for Friday. In Monday's folder was the little notes about finding C, a very short homework assignment or classwork assignment. Some of you turned it in here, some of you turned it in electronically, 1 to 8, 15 to 18. Okay, this was a video, so you can watch another video about figuring out the missing number in the antiderivative problems, and these are the notes that went with it. Okay. The lab I'm talking about was in Friday. This is the lab assignment, and if you were trying to figure out where the data was, the data is here on this PDF. So I was fiddling around with my Google Doc. I'm not very good with Google Docs. I was fiddling around with my Google Doc. I decided just to put a PDF of the basic information here. So there's your lab, the data for your lab, and then there's all the questions. And then there was a Google Doc that you could put your answers in and turn in. Okay. In between those two, the Wednesday work, the 23rd, this was just another little example about going from marginal cost to cost function, marginal profit to profit functions, 5 problems to do there. Okay. So, questions about, right off the top of your head right now, the lab or any of the other assignments from last week apart from the project? If you think of anything,